Welcome back. This is episode 3 of TGIR RabbitMQ Season 1. My name is Gerhard, and today I will show you how to give back, how to contribute to RabbitMQ. I hear that many of you are getting bored at home, and if you're looking at doing something different, something that will challenge you, something that you haven't thought of doing when you woke up in the morning, I think I can help. Let me show you. So, this is what I mean when I'm thinking about someone that wants to contribute to RabbitMQ. From our perspective, from the engineers on the RabbitMQ team, obviously it's very simple to do that because that's what we do all day. But for those watching, maybe it's too daunting. Maybe you think, I wouldn't even know where to start. So let me show you. Let me show you what it means to go from not having anything on your machine, not even Erlang or Elixir, the two dependencies that we'll need to build and run RabbitMQ. So from not having anything, we will set up a RabbitMQ development version locally. We will run it. So we'll run our development version. We'll look at the different options that we have, the different things that we can do there. We will build and test a custom RabbitMQ, and we will do that in response to a fix that one of our team members did for an issue that we discovered in episode 2, and we'll look at that in a minute. And hopefully we'll close the issue right when we confirm that the fix works as advertised, and then we will cover what is coming in the next episode. I would like to keep it within 30 to 40 minutes. Regardless how bored you are, I don't think you can take more than 40 minutes of doing this, of watching this. So with that in mind, let's just get cracking. I have the TGIR repository cloned, github.com, rabbitmq, TGIR. You can go there, you can find the link to clone it. And when you do that, you will go into Season 1, Episode 3, which is the current one. And you'll see 2 files in that directory. The first one is the README, which contains the show notes, which contains the links, the timeline. Have a look, everything related to this episode. And the other file is the Makefile. And if I do make help, you'll see the type of targets. You'll see the targets which are available there. And these are the ones that you'll be using to, these are the ones that I'll be using and you'll be using to follow along. The reason why I like to put things in make targets is so that typos are avoided and the focus is on what we are trying to achieve and less on how we are going about it. So while we run these things, we make sure we don't have any typos. It's very easy to remember them. It's easy to discover what the commands are. So we can see, for example, here, everything that's possible within this episode. And by the way, all other episodes behave exactly the same. And also going forward, I intend to do the same thing for all other episodes. So we will start by cloning the RabbitMQ public umbrella. And as I do that, as I start that off, that will take maybe 4 or 5 minutes. And while that happens, we can talk about various things. So make help, the command, the target that we want to run is make public umbrella. So by the way, my M is alias to make. So whenever I type M, I'm actually typing make. And if I do rabbitmq public umbrella, I can autocomplete. And I'll show you in a second how to set that up. But let me just kick off this command. So as this is happening, let me show you something very quickly. So in the same repository, I just opened a new tab. So I'm in the same place. And if I do M and if I tab, I only see the files. But there is a .end file. So if I source the .end file, which by the way, it's just a simple script, simple shell script, which it will add auto-completion to my bash shell, which is the one that I'm using here. And once I do that, once I source that file, which I did up here, right, I source the file. Now I can tab and it will show me all the different targets which are available. So in my case, when I do RA and I tab, it will automatically complete that. If I do mdev, it will show me the different commands that are available to me. So now let's jump back where this is being set up. and we will notice the command that gets run. So first of all, we clone the rabbitmq public umbrella into the rabbitmq public umbrella directory. And after it gets cloned, we run another make target in the context of the rabbitmq public umbrella. And the make target that we run is up. So what this does, it will actually clone all the components. It will clone all the repository for all the rabbitmq components. RabbitMQ public umbrella is nothing more than just glue, right, that holds all the different RabbitMQ components. And this includes all the plugins, this includes all the dependencies for those plugins, and also some of the clients, some of the like more popular clients. And these are like the ones which we maintain ourselves, and they're all cloned with just one command. So the command to run to get all the RabbitMQ components so that we can recreate everything that we need locally for RabbitMQ development is, after we clone the RabbitMQ public umbrella, is make up, but make up in the context of the RabbitMQ public umbrella directory. What I'm doing here, basically I'm saying make, and I'm telling make to change directory. In this case, go into the RabbitMQ public umbrella directory, that's the one that I cloned up here, and then run the up target in that context. So this will take a while because many different dependencies are being cloned, some are being compiled, but once this finishes, which as I said takes between 3 and 4 minutes, I'll have everything I'll need for RabbitMQ development. So while we wait for this to complete, I will come back here and I would like to cover the master branch and the difference between the master branch and the 3.8 branch. So by the way, when I type make, it's like make help. I can just type make and that's the target that gets executed by default. So when I do M, I'm just typing make. And the target which I would like to run is which release series. So which release series will show me all the components that have been set up locally, and it will show me the branch that those components are using. The master branch, in this case, refers to the next RabbitMQ miner. So right now, the RabbitMQ miner that that is in support is RabbitMQ 3.8. And RabbitMQ 3.8, once it has been released, once it went GA with the 0.0, a new branch was created, which was the 3.8 branch, the v3.8.x branch. And the master branch becomes automatically the next miner. So in this case, the master branch contains, or basically, the master branch represents all the components that will become part of RabbitMQ 3.9.0 when we release that. And that's where all our development happens. If there's anything that needs backporting, any feature that we want to introduce into 3.8 or even 3.7, we would commit it to the master branch first and then cherry pick it to either 3.8 or 3.7, or based on how many minor release series we are supporting. So right now, as you already know, we covered this in episode 1, by the way. 3.7, it goes out of general support at the end of this month, so in a couple of days we'll be out of support, which means that we will be supporting the 3.8 release series, and that's where the 3.8 branch comes in. And we'll also be supporting 3.9, which is like the current master, as soon as we are ready to ship it. So we can see that all these components are at the master branch. So we have another make target, which is switch to. So if we run switch to 3.8.x, what's going to happen when we run this command? It will go through all the RabbitMQ dependencies, and it will make sure that we have the 3.8.x branch checked out for all these dependencies. So if you wanted to build a development version of 3.8, we would need to make sure that all these dependencies are checked out at 3.8, and then we can build or run locally That's how we get a 3.8 RabbitMQ. In our case, if we do check out the 3.8 branch for all these components, what it means is that we are working on what will become the next patch. And in this case, the next patch is 3.8.4. So to see what 3.8.4 looks like right now, we would need to run this command and then run the next command, which would start RabbitMQ. So let's do that. Let's start a local dev copy of RabbitMQ. If we take a look at which release series we have, we'll see that all of these components, there's some exceptions, the clients, and by the way, the clients are not part of RabbitMQ. The clients are there, so it's easy for us to work with them and run them against the local RabbitMQ version, which is the development one, but they are not part of RabbitMQ. The plugins are though. So like RabbitMQ WS, for example, RabbitMQ management, all these, they are part of RabbitMQ. So once we have all these components checked out at 3.8, to run a local development copy of RabbitMQ, there's a command make dev server. So if I run this command, the first thing that needs to happen, because in this case, this is a fresh setup, every single dependency or every single component, dependency and component of RabbitMQ needs to be compiled. There's quite a few things which need to be compiled. It shouldn't take long, a few minutes at first, and then obviously going forward, they get cached. So only the files that change will need to be recompiled, and the system automatically figures that out. So the one thing which we haven't seen is when did the dependencies get resolved? Specifically, when was Erlang installed? When was Elixir installed? Which are the dependencies that we need to compile and run RabbitMQ? The reason why we didn't see that is because the make deps command, the make deps target that we run, there was nothing to be done for it. And the reason why there was nothing to be done for it, I'll open up the Makefile and we'll see what goes into the deps. So the deps, we set up Erl, we set up Mix, and we set up the RabbitMQ public umbrella. The RabbitMQ public umbrella we've already cloned, so there's nothing to be done here. When it comes to Erlang and Mix, the reason why nothing ran is because I already have them installed. So if we take a look at Erl, so Erl, it will try to look for the binary in user local bin Erl. If it doesn't exist, if the binary doesn't exist, it will install via brew install Erlang. So this is what happens on the Darwin platform, which is mine, like Mac OS. I'm using Mac OS here. So in the context of Mac OS, this is the command that would run, and it would require brew, the Mac OS package manager. And if this doesn't exist, it would install it. Otherwise, it will try and default. If the platform is any different than Darwin, it defaults to user bin Erl. And if that doesn't exist, it will ask you to please install Erlang 22 or newer. So if you're, for example, on Linux or anything else, or any Unix platform really, it doesn't matter whether it's Linux or BSD, and Erlang, specifically the Erl binaries, doesn't exist at that location, you'll need to install it for your platform. Same thing for Mix. And in this case, Mix is like Elixir. Mix is the binary that we use, but Elixir is the name, right, of the dependency. And the requirement is that, again, on Darwin, it will just get installed. Otherwise, if this is a non-Darwin platform, then you'll need to install Elixir 1.9 or newer. Again, the reason why we haven't seen this in my case, because I already have them installed. And if the dependency is already resolved, there's nothing to do, and that's why we've seen the make deps, nothing to be done for deps. There we go. We can see that we have RabbitMQ running locally, and this is what will become 3.8.4, as I was saying. And the next thing which I would like to cover, now that we have it running, yes, I would like to cover the interactive shell. So the interactive shell, if I press enter, I'm basically in the interactive shell, because when the node starts, it starts it with a shell. So I can interact with the Erlang VM. So one command that you are typically used to running from the CLI is rabbitmq, on the command line, is rabbitmqctl status. I can do the same thing, but from within RabbitMQ. I can do rabbit, and I can tab this. And rabbit is the module in this case, and the command that I would like to run is status. It takes no argument, so rabbit status, the parentheses dot, is the equivalent of running the rabbitmqctl status. We can see that the formatting, this is the default Erlang with all the terms and maps and lists and everything else. And the dots in this case, it basically means there's more, but by default, not everything is printed. So the command that I use, or the function, I should stop calling it commands. In this case, it's a function. So the function which I use is rp, and what I would like to do is run the last command. So basically rerun the last command, but run it, wrap it in the rp function. And if I run that, I get the rabbitmq status formatted in a way that is showing me all the contents, or I get basically all the output. So in this case, we can see the running applications, memory, this will be familiar to you, and all the other properties. Another interesting command, which will show you, I mean, you'll see, like, for example, we can see where the log files are stored, we can see where the enabled plugins are stored, so on and so forth. Another interesting command is rabbit environment. So I'll do rp rabbit environment, and this will show us the entire configuration for RabbitMQ and all the components. So we see a lot more, for example, RA. RA is, as you will know, the library that is used by quorum queues. That's what keeps all the consensus in the context of quorum queues. Obviously there's Rabbit, which is the core and all the configuration for it, but as well as Amnesia, the Observer CLI, and many other things, the log handling. So the Rabbit environment is the, in this case, the function, right, to call to see the entire configuration of all the components that make RabbitMQ. Okay, so we explored the interactive shell. I think the next thing we would like to run is get a development copy of RabbitMQ with all plugins enabled and standard out debug logging. Right, this is really cool because we can see everything that is happening within RabbitMQ and all its components at a very low level. So to quit, right, this is like the old Vim joke. How do you quit Vim? Well, you don't. So how do you create RabbitMQ in this case? Very easy. Obviously, right? Get the joke. Control G, switch command Q, and that's how you properly exit from a, in this case, an Erlang VM. You can also do like init stop. You can do that as well. But this, like this key combination, Control G and Q, is the simplest one. So once I got out of here, let me go back to my first tab. There we go. Where, oh, by the way, we can see it took roughly 4 minutes. So I would expect, in your case, take the same amount of time to set everything up. Now, as you'll remember, we will have switched to 3.8. So I would like to go back to 3.9, which is master. So switch to 3.9, which is like our developments. We are properly on the edge of RabbitMQ. We have all the latest features and all the latest all the latest features that may not even be backported to 3.9. Sorry, to 3.8. Because that is always the case. There's always something which is new that has not landed in 3.8 yet. So this makes sure that I have the latest and the greatest Rabbit locally. So this will take roughly 45 seconds. We're almost there. And remember, what we're trying to do here is run a local development copy of RabbitMQ with all the plugins enabled and standard out debug logging. There you go, that's finished now. So dev server, and there is a make target dev server all plugins. So rather than running this command, I would like to dry run to show you what happens behind the scenes. Let me bring that up a bit. So we change the directory, we go into the RabbitMQ public umbrella. That's where everything is checked out. That's where everything will exist. Dependencies, the rabbitmq-server release. And once we go in the rabbitmq-server release, by default, all the plugins will be enabled when we run broker. So this is the make target that we run in this directory, make run broker. and we set rabbitmq logs to dash. That's what sets rabbitmq logs to standard out. That's the simplest way of sending rabbitmq logs to standard out. This is an environment variable. This works in any environment, including Docker. By the way, that's how Docker gets configured, the Docker image, to output logs, all logs to standard out. So let's take a look at what the dev server command was in comparison. So the dev server, we went into the rabbit directory, and if I do that, just to show you what the remote is, this is rabbitmq-server. So you will see how if you were to clone just this directory, you would have only the broker and none of the plugins, none of the other things that are also part of RabbitMQ. So that's why we clone the umbrella, to get the whole lot. So if I run, let me come back, and if I run this command, make dev server all plugins, behind the scenes, we've seen what gets run. This will go into the RabbitMQ server release, and it will do run broker. Now you will notice that some things have to be recompiled. The reason why that is because we switched from 3.8 to 3.9, and there's some differences between 3 and 3.9, so a bunch of these files need to be recompiled. It shouldn't take long. I expect this to complete within 20 to 30 seconds. And once we do that, once we see that happen, we'll get a RabbitMQ 3.9 development version running locally with all the plugins. Right, now I remember why this will take slightly longer. Okay, the reason why this will take slightly longer, longer than I thought, is because before we only ran the RabbitMQ broker, the core of RabbitMQ. We didn't run any of the plugins. And what that means is that none of these files have been compiled before. So we literally have to compile all the plugins, right, from Erl source code into the Beam files, which is what the Erlang VM uses to run. Okay, so this is the last bit. We can see all the plugins, they're being enabled. There you go, we can see all the plugins, and we can also see this debug logging, which in this case has, I'm not sure, oh, interesting. Okay, so this is my terminal, so let me just do that. Can I do that? Yes, I do. Command A to select everything. I'm using a different background. I'm using a white background for the purpose of the recording, just like so that things are look a lot better on your screen. And when I do that, so when I use Command A, the problem is that some of these just don't show up, especially like the bold ones. That's something which I think we would like to adjust. We normally run this, so you can already tell, right? We run this on the black background, and that's why we can see them. So that's a fix that we can do, right? Maybe in the next episode. So part 2, right? Definitely part 2 of contributing to RabbitMQ. So we can see in the startup, we can see all the plugins that have been enabled, everything that ran in the context. We can see the debug messages. This gives us a lot of detail of what happens behind the scenes, and it's all on standard out. So you don't have to go looking for any files. We don't have to, be tailing or grabbing or whatever, loading in our editors, any of the log files. Everything that we need is on standard out, which is really, really helpful when we are developing RabbitMQ. So, okay, we have everything. We have a RabbitMQ, a local dev copy of RabbitMQ with all the plugins enabled and standard out debug logging. The next thing that we would like to do, I showed you obviously how to reuse the interactive shell, but the next thing that we would like to do is where to find rabbitmqctl and friends. So I'm just going to open a new tab. I'm still in the same directory, season 1, episode 3. And the command that I want to run, let me source env. The command which I want to run is show CTLs. That's the one. So show CTLs. It shows me that in the RabbitMQ public umbrella, in the deps directory, Rabbit, there's an sbin directory, and there we have all the commands, all the CTL commands that we can run. So RabbitMQ diagnostics, for example, RabbitMQ plugins, RabbitMQ queues, RabbitMQ upgrade, and RabbitMQctl, which is what most of you are using. By the way, you can see there are other commands. You may not have known them. You might not have been aware of them, but this is where they are. This is where you can find them, and this is where you can see everything that's available. So let's go into that directory. Let's jump here. These are all the commands. So let's run, in this case, rabbitmqctl status, right? Typo. See, as long as I'm just like, once I don't have my shortcuts, I can't type, right? Bad developer, some say. Anyways, rabbitmq status, we can see an output. This is a nicely formatted one. This is, I think it's already available in 3.8, but we had the default Erlang output for a long time. Some team members did a great job in adding this much nicer human-friendly format, so we can see the equivalent of running rabbitmq status on the command line. We can see, there you go, all the plugins which are enabled. That's literally everything that we have locally, and where the config files are stored, and yeah, a bunch of other things that you would expect to see here. So we've seen rabbitmqctl, we've seen all the other commands. So for example, rabbitmq upgrade. Let's take a look at that command. You may not be familiar with it. If we just run the command with nothing else, we should see what is available. Post upgrade tasks, very nice. And we can do help just to see what we have there. So it's like a nice description of what that command, how to use it, what it is, run post upgrade tasks. I just realized that the one thing which I would like to show you is the manual pages, because we have the entire RabbitMQ source code and literally everything that goes into RabbitMQ. This includes not just the commands and the documentation, but it also includes the manual pages for all these commands. Okay, so man, we found where they're stored. Man, let's take a look at rabbitmq upgrade.8. Cool. So this is how we can look at the manual page for not just, in this case, rabbit upgrade, but also any other command. And this is what, if you have them configured correctly, after RabbitMQ is installed, you can do just man rabbitmq upgrade or man rabbitmqctl, and you get the manual page for that specific command. What we're looking at here is the rabbitmqctl manual page. There's a lot of good stuff in here. You can see all the options, all the commands, all the flags, literally everything that you would want. And if you haven't seen this before, this is such a great resource to understand better how the different CTL commands behave. So I strongly encourage you to spend a bit of time with this. Okay, so we found RabbitMQctl and friends. We know how to run them. That's what we looked at before. We know where to find the documentation for all the commands. And now that we have covered the basics, we can go to the next stage, which is building and testing a custom RabbitMQ. So what we want to do is build a Docker image that includes 2 dependencies checked out at a specific version. We want rabbitmq-server 2279 and rabbitmq-common 368. And let me go back to the issue and explain why these are important. So in episode 2, we were looking at the gap, right? And we're trying to understand why that happens. And as we understood what that gap actually represented, we created an issue explaining of what we've observed, what was happening. And in this case, the RabbitMQ node was using a lot of memory during startup. And the reason why that was happening is because the queue index was being rebuilt and we had a lot of messages. So it's a problem, right? It's a problem when if a RabbitMQ node starts, it needs this much memory to process the many millions of messages which it has. So in response to this issue, Philip Kurilowski, he's a RabbitMQ team member, he added a fix. So his fix was reduce memory usage during startup, which is 2279. This is the pull request that I referenced. And the branch that we want to check out for rabbitmq-server, in this case it's Rabbit, we'll get to that in a minute, is startup memory fix. Now, this is not enough. We need this, and we'll see this a bit further down. There you go. We need rabbitmq-common, pull request 368. We need these two things checked out so that we can build a version of RabbitMQ that has the fix that Philip implemented. So let's do that. Let's take a look at, in this case, if I go back to, let's go GitHub, rabbitmq TGIR season 1, episode 3, and the command that we want to run is checkout PR 2279. So let's see what will happen behind the scenes, and let's focus on this a little bit. So we will go into the public umbrella, we will check out master, yes, and we'll make sure that all the components are checked out at the master branch, right? That's our starting point, 3.9. And then what we want to do, we want to go into the RabbitMQ public umbrella dependencies Rabbit. This is rabbitmq-server, by the way. And we want to check out the startup memory fix branch. And that is basically this one, right? We want to check out the startup memory fix branch. And we want to do a similar thing in rabbitmq-common. We want to check out the worker pool dispatch sync. And this is this branch. I know that these pull requests have been merged, but normally we have to create the build and verify that these pull requests work before we merge them. And I haven't done it. Apparently Michael, he's the reviewer. Michael already did this, right? So he's confident that this works. I would like to verify that, and I would like to see that indeed this fix works as advertised. So let's run this command. And by the way, okay, while this runs, let me go back here and let me stop this. So Control-G-Q, right, to stop the running RabbitMQ node. Now we are checking out all the dependencies at the correct version. This will take, again, about 40 seconds, 50 seconds. And the next thing that we want to do after this is checked out, we would like to build a Docker image. To build a Docker image, we have a target in episode 3, a make target, make Docker image, which changes directory into the RabbitMQ public umbrella deps rabbitmq-server release, where it runs the same target, Docker image, and it provides a single variable, which is the project version. This is what will get used in the Docker image tag, and it's the same one that will be used in the RabbitMQ version. In this case, I'm setting it to the RabbitMQ minor series, as well as today's date. So when this target runs, the first thing which happens, it will create a generic Unix package. And the generic Unix package in this case has already been created because I ran this command before. In your case, it will compile all the files which need compiling. It will grab any extra dependencies which are missing, and it will create a tar.xz, an archive of all the components that make RabbitMQ. You can see all the licenses, you can see all the scripts, you can see all the plugins. Literally everything that goes into making RabbitMQ will be in this archive. All these files will be added to via Docker file to the same, so we're using basically the same Docker file that the official RabbitMQ Docker image is using. And the only difference is that rather than downloading RabbitMQ from a public repository or a bin tray, package cloud, or like a couple of places where we distribute and make RabbitMQ available. So rather than downloading it from those public places, we are copying the RabbitMQ that we have built locally. And that's how that ends up in the Docker image. one of the things which happens is Erlang gets compiled from source, OpenSSL gets compiled from source in the image. So if you haven't run this before, it can take quite a bit, 15 minutes, 20 minutes. But because all the layers get cached, after they're cached, it's only the ones that change need to rerun. It tends to be fairly quick afterwards. In my case, we can see that we have tagged the image. The next thing which happens is this gets pushed, and it gets pushed to hub, into Docker Hub. So it's publicly available. Anybody can download this image when we publish it. You won't be able to publish it obviously to this org, to this Docker Hub org, because you'll need a login, which you won't have. But you can change this to publish it to yours, or just run it locally, right? There's no reason to publish this image, this Docker image, somewhere publicly if you don't want to be consuming it. So to run it locally, we have docker image run, and all it does, it runs the image that we have built, and this is locally, and it will map port 15673 to 15672 so that we can access management. And if I run this command, I'm effectively starting a Docker container using this image that we've just built. So we have it up now, it's up and running. Let's take a look at management. We can see the node coming up. We can see the node name, and yeah, there we go, that has changed. So I ran this before, we have a new node name. So this is running a RabbitMQ container. We have the Erlang version, and we can see the RabbitMQ version. We have 4 plugins, 2 plugins enabled. Yeah, 2 plugins enabled, the RabbitMQ management and RabbitMQ Prometheus, which is what happens by default when this image gets built. So the reason why I mapped a different port, 15673, is because I also have the RabbitMQ running that we started locally. So I'm just going to, no, I want to continue. I want to do Control GQ, and I'm going to start it. So we're going to start RabbitMQ a local dev build, same as before. And this I think we did earlier, but I'm doing it again here just to show you that I can have both running side by side. There we go. So the local development version of RabbitMQ is running, and this is this one. So this is running on the host, and we are accessing the management. And when it finishes booting, we'll be able to see all the plugins that you'll get enabled. There we go, 42 plugins. So when RabbitMQ gets started like this, we have all the plugins enabled, and this binds to port 15672 for the management, as well as all other ports for all the other protocols. And I have the RabbitMQ running in a Docker container, which is on my host here. And I have also RabbitMQ running locally on my host. So the reason why we want to do this is because we want to test the fix in the context of a host which is identical to the host that we used last time in episode 2. And that's why running it locally, it's okay, and we can test certain things to some degree, but we want to make sure that we have the same environment with the same specs. Like, for example, we may need 128 gigs of RAM, and while we can get that locally in a machine, I would much rather pay someone like GCP or AWS or some other cloud provider where I can spin up one of those beefy machines, use it for half an hour, take it down, and a few dollars later I will have tested the fix in a context which is maybe much bigger than my machine supports. This is especially useful if you have larger clusters or bigger clusters and you need multiple nodes. It's fairly easy to spin these big nodes up using a specific RabbitMQ version that you couldn't do locally. You couldn't create a VM that big locally. What I've done in episode 2, so same repository in episode 2, I reused that Makefile, and I've modified the Docker RabbitMQ image in that Makefile. So by doing that, I could deploy a RabbitMQ broker with this image, right, which was built yesterday. So you can see 25th, that was yesterday. And I've already deployed it. So if I do, again, I'm in episode 2, we can see all the make targets. The one that I want to run is make instances, and you can see what runs behind the scenes. So we have the backlog, the container that will create basically a backlog of messages, and we have the RabbitMQ durable, which is the broker, the RabbitMQ broker, and let's take a look at that. So we can do make, let me do env make management, and I would like to run RabbitMQ durable. So this will just basically open the management for that RabbitMQ management for that node. We can see that this one here is RabbitMQ 3.9, and it's the version that was built yesterday. And this is running, so behind the scenes, if I was to run RabbitMQ durable, I'm not going to run the command, I'm just going to dry run. It will it'll run gcloud, compute instances, create with container. It will give it a name, right? And the image which will be used, it's right here. So it's the image which we build and publish to Docker Hub. And that's the one that will be picked up. Okay, so yes, we were looking, yes, so we have this image build, it's running, we have a backlog. I've been running this for a while before I started this recording, and we have the 50 million messages in, we have basically a backlog of 50 million messages. So to test if this fix works, and basically to test if we can, if we can fix this, right? If we can close this issue, say yes, the fix, accept the fix, we need to rabbitmqctl stop app and rabbitmqctl start app and see how much memory RabbitMQ uses. In this case, we can see that it was using 56 gigs, and we also want to see how much, how many disk reads we have and how much memory is being used from a net data perspective. So let's do that. Let's open up a couple of things here. So let's open up, let's do net data RabbitMQ durable, and this will open just as it was opening management. This is already running, by the way. I had it set up a while ago. This will open net data, which will give us real-time view into the system metrics. We're looking at CPU. I think the interesting part is memory. Let's see how memory usage will change. And is there a different one? Was it system overview, CPU, disk? Here we can see reads and writes, RAM. This is the interesting one. So you can see we're using about 10 gigs. And let's see what happens when we stop app and start app. So we have net data running. So now let me open up a shell on the RabbitMQ durable node. This will open up a shell, so rabbitmqctl status. I've opened up a shell in the context of the container that runs on this node, right? That runs on this VM. So I'm there, rabbitmqctl, I can see the name of the node. There we go. I'm definitely connected to a remote host, so I'm there. What I would like to do is rabbitmq run the observer CLI. This will basically give me an end curses interface into this node. Yes, typo. Okay, and again, the color scheme isn't helping us, but if I do Command A, it will, we won't have colors, but at least we'll be able to see everything. So now that we have this up and running, I just need to stop app and start app. So let me run that command again. We go to GitHub rabbitmq TGIR, season 1, episode 2, make bash rabbitmq durable to open a shell on that node. And I want to do rabbitmqctl stop app and rabbitmqctl start app. Okay, I'm not sure why that happened. RabbitMQ, that was an interesting one. RabbitMQctl stop app, RabbitMQctl start app. Okay, so these are the two commands. We're running them in succession, stopping and starting. Let's see, basically we have them described here, right? We restart the app. So let's see what happens from a system perspective, how the resource usage changes, and specifically memory, right? Because that was the interesting one. So it's still stopping it, it'll take a while. And we can also look at the observer to see what changes within the Erlang VM. By the way, we are not stopping the Erlang VM in this case. All that we do is stop the RabbitMQ app. which will take down many different applications and basically all the dependencies. So everything that runs in the Erlang, in this Erlang VM that represents RabbitMQ will be stopped. I think it's still stopping. I can't remember how long it took last time, but I think it was a couple of minutes. So we'll see. More importantly, we want to see the startup, how much memory it uses and how long it takes. Okay, so the node finished starting. Let's see what happened in that duration. From a memory perspective, because that's what we're interested in, it went from, it just booted 1 GB. It increased all the way to about 9 from 1, but we didn't see that massive spike that we had before. So just to, I can close this now. I can keep that open for a while. So looking here, actually this is the giveaway. Looking here, what we had before, we had this like growth, massive growth. We see nothing like that now. So from the perspective of the memory, a slow ramp up, and that is the equivalent of what we had here. No big spikes, no tens of gigs of memory being used. This is almost perfect. So let's see if we can close, right, this issue, because that's our contribution, right? We want to verify that the fix worked, and we want to provide all the details, all our observations in a way that would basically close this issue. So I did that, right? I've just tested this in the context of TGIR episode 3, and I confirmed that this PR fixes it. The memory usage doesn't go above 8 GB, and even though the recovery time didn't improve, the memory usage was perfect. The ETS data structures used expected memory. All our other components only used what they needed. Watch the video if you're interested to see how this was confirmed, and these are the 2 important screenshots. We had the memory one, that was perfect, and we can see the disk recovery and the traffic before and the traffic after. This was specifically the disk usage, right? All the messages are durable, they're going to disk. And the important one, I think this is a good one to see how the bulk of that memory is used by the Rabbit message store ETS index table in ETS. Perfect. That is perfect. Okay. So let's close it. 1, 2, 3. Excellent. Now that we have closed this issue, let's talk about the next episode and what to expect. So I would like to go over previewing docs locally. This is basically the rabbitmq.com website, making changes, submitting PRs. That's like a different way that we can contribute, you can contribute. Then I will look into setting up a RabbitMQ development environment with a single command. This is helpful if, for example, you don't want to be installing Erlang, you don't want to be installing Elixir, or you're in Windows, and you may want to have an environment already set up for you, which is ready for developing RabbitMQ. We'll have one command to do that. And then we will look into the meaty part. This is where we were trying to get to, but you can see there's like so many other things that we needed to set up. And I didn't want to make this episode too long. It's already more than I was expecting. I was going for 30-40 minutes. It's slightly longer now. That's okay. But this is something that we'll need to do next time. And this is, I think, where the meaty part is. There's like a lot of interesting discussions of how to do things, how to run tests, how to get like interactive shells in like different contexts, breakpoints, so on and so forth, how to do profiling maybe. We'll see where this takes us. And then we look into how to submit a PR, right? So we were working in this context, we were working with an existing PR that was already submitted, and it was submitted across multiple repositories. So we will do the same, but we'll do the same from scratch. So we will be the ones that will finish that episode exactly where we started this one. So it's a little bit backwards, but I felt like these were the prerequisites for that next episode. And with that, thank you very much for watching. See you next month.